So after watching those two videos about the p-value, this is what we get as a definition of the p-value. The p-value is the probability of getting unusual results or more unusual results if HO is true. If the p-value is low, HO is go, and I'm going to write the conclusion right here, which we're going to see actually later also. P-value less than alpha, reject HO. P-value more than alpha, you fail to reject HO. And fail to reject, guys, doesn't mean you accept. If you, as students, makes an argument with me and I just get tired and I don't want to discuss it anymore, I said, okay, I'll do it. I'll go along. It doesn't mean that I accepted the argument. It's just failing to reject doesn't mean accepting. So don't change the word fail to reject, guys, with accept. Just leave it always as fail to reject. Okay, let me tell you some more definitions before we do a complete problems, guys. So what is a right test, tail test? What is a left tail test? And what is a two-tail test? When you have the null hypothesis and the alternative is stated like this, let me just give you an example. Greater than means going to the right. So when the alternative sign has a greater than, this is what we call a right tail test. Left tail test, I think, guys, you know what the left tail test now, when you have a less sign in HA. That's an example. You're going to see some homework problems. He will give you two hypotheses and tell you, is this a right tail test, a left tail test, or a two tail test? You just look at the alternative. If it is greater than, it's a right tail test. If it is a less than, left tail test. And now, guys, you can tell what's going to be for two tail test. Equal or not equal? When I say the mean is not 15, that means it could be less than 15 or more than 15. That's why we call it a two-tail test. Different from sign. In HA. And here again in HA. Any questions about those definitions? Okay. Let's go to the next one. For each claim, state HO and HA, then determine whether the hypothesis test is a left tail test, right tail test, or two-tailed test. A school publicizes that the proportion of its students who are involved in at least one curricular extra activity is 61%. So we did this example before, guys. We stated the null and the alternative to be P equals 61% and P not equal to 61%. And since this is not equal, this is a two-tailed test. Okay. He said sketch, this one. Let me show you how to sketch this one. The normal curve showing, you just do this. And since it is a two-tailed test, the p-value, guys, could be on the right or on the left. So you just shade two areas here for the p-value, which we're going to talk about in details later. So this is what a two-tailed test would look like. A car dealership announces that the mean time for oil change is less than 15 minutes. Also, we did this one, guys, earlier. Less than 15, greater than or equal to 15. And here's how you sketch it. Sketch the p-value. The p-value is an area to the left because this is a left tail test. This is your p-value. And these are the p-value, two of them. They're the same, they're both tails. Okay, let's do the third one. A company advertises that the mean life of its furnaces is more than 18 years. You can see, guys, where we're heading to now. More than 18, less than or equal 18. And here's how you sketch it. You're gonna see the calculator even will sketch. This p-value that Helen found, in the exercise and the video that you watch, and that p-value that they found in the first video will be an area to the right here because this is a right tail test. Okay. Now, where is the decision rule based on the p-value? I wrote it on the previous page, but it is already here. If the p-value, guys, less than or equal to alpha, you reject HO. If the p-value is more than alpha, then don't say you accept, you fail to reject HO. You really need to memorize this. This is the key, guys, of performing hypothesis tests, especially when we use the p-value. You need to memorize this. I tell students always when they take a class, exam, just in class, about hypothesis testing. Once you start the test, write down those two statements, and so you don't forget them, because you're going to be using those two statements throughout the exercises. You will see, guys. Okay. I'll come back to this in a little bit. Okay. Let me write them down and then we'll emphasize on them, when we do an exercise. So you have your claim in HO and you reject HO. So your claim happened to be in HO and your decision end up rejecting HO. That means you reject the claim because the claim happened to be in HO. So you say, this is the conclusion of a hypothesis test problem. You say there is enough evidence to reject the claim. So if you guys make two statements, HO and HA, and the claim happened to be in HO, and we reject HO, that means your claim is rejected because it is a part of the claim. The claim is in HO. So if you reject HO, for a reader, you tell a reader, we have enough evidence to reject the claim. If the claim is in HO and you fail to reject HO, can a student tell me what would be the statement? It's going to be an opposite to the previous one. So you claim in HO and you fail to reject HO. What would you say? There's only one word you have to add to this statement. Who can tell? In the previous one, we say there is enough evidence. What would be if you fail to reject HO? Exactly, Samantha. There is not enough evidence to reject the claim. If I don't reject the claim, guys, it doesn't mean that I agree with it, but I just don't have the means to reject it. I don't have the evidence to reject it. That's why in the court case, they say you gotta have evidence beyond reasonable doubt, not just any evidence, beyond reasonable doubt. So when the claim is in HO, guys, we either reject the claim or fail to reject the claim. We can reject the claim. Let's see if the claim is in HA, which is the likely case, guys. Usually most claims should turn out to be in HA. So your claim is in HA and you reject HO. So we have HO and HA. Your claim is here, guys. And you reject the first one. That means your claim is true. It is valid. So you just support the claim. You say there is enough evidence to support the claim. So we use the language of support when the claim is happen to be in HA. Here we use either reject or not reject when the claim happened to be in HO. Okay, fourth scenario. These are all the scenarios, guys, in a hypothesis test. No other scenarios. So when you do any problem, at the end, you have to write one of the four statements right here. You have to choose one of them and write it down. If the claim is in HA, but you do not reject HO. So our claim is here, guys. But we cannot reject the first guy right here. That means we say we cannot support the claim. So it's just there is not enough evidence to support the claim. We will put all of this in practice once we do an exercise. So we're not there yet. Okay. You perform a hypothesis test for the following claim. How should you interpret a decision if you reject HO, if you fail to reject HO? Okay, let me go to the page. Okay. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So let's put the null and the alternative. That's very important, guys. And this is the claim. And HAP is not 61%. Okay. If you reject HO, what do you say? If you reject HO, guys, and the claim happened to be in HO, you just reject the claim. So you say there is enough evidence. There is enough evidence to reject the claim and just copy it and paste it. That the proportion of students, I'm just copying and pasting the claim, guys. The proportion of students who are involved in at least one extracurricular activity is 61%. We're rejecting that. So we're saying that your claim is false. That's when you reject HO. If you fail to reject HO, guys, you just add the word not to this. There is not enough evidence to reject the claim. And I'm just gonna capitalize this, enough evidence to reject the claim. And then you can write it down if you want. I usually want students to write it down because your last conclusion in a hypothesis test is to make it for a reader who doesn't understand the statistics. They need to know whether what that claim is valid or not valid. They don't care about the work that you did prior to that. It's just a final statement. And let's look at number 2. A car dealership. Okay, let's see. Claims that the mean time for oil change is less than 15 minutes. So let's write the null and the alternative, guys. Mean is less than 15 minutes. And look now, I made up this question now so that the claim will be in HA. Remember, when the claim is in HA, we don't use reject or fail to reject. We use support or not support. So now the claim is in HA. Let's see what the language. If you reject HO, what do you say? If I reject HO right here, so I'm saying this is bad, that means this one is good. I just support it. There is enough evidence to support the claim. And then you can say what the claim is. The claim that the mean oil change is less than 15 minutes. If you fail to reject HO, guys, and your claim happened to be in HA, that means you cannot support the claim. So just change this statement and just add not here. There is not enough evidence to support the claim. So guys, before we move on and do a complete exercise, these are the 4 conclusion scenarios. So you're gonna always have to select one of them for the final scenario, final conclusion. It's this or that. You can't have 2 at the same time. It's either this statement or that statement. You use one of the 2 statements when your claim is in HO, and you use one of the 2 statements when your claim is in HA. You use the first statement if you reject HO, the second one if you fail to reject HO, and same thing here. You use the first statement if you reject HO, and the second one if you fail to reject HO. Finally, these are the 5 steps that I'm going to perform to complete to do a hypothesis test. First of all, we're going to state the null and the alternative hypothesis, identify the claim. Then we're going to transfer the data from the sample to a z-score. Then we're going to use the z-score to calculate the p-value. And based on the p-value, guys, if the p-value is less than alpha, we're going to reject HO. And if the p-value is more than alpha, we're going to fail to reject HO. That's number 4. And number 5, guys, we're going to write the conclusion in the context of the claim, which is this. There is enough evidence, there is not enough evidence, etc. Before we get to that, let's do some algebra. Let me show you the algebra, guys, that you need for this one, the support, just that you need. You're gonna need to learn how to do something like that onto a calculator. So let's do it and see how to do this on the calculator. So have your calculator handy. And if you are to calculate the z-score here, 110 minus 105 over 12 over square root of 35, how would you do that? Here's how I would do it on the calculator. Watch, guys. You put open parentheses first and put 110 minus 05. And then put division and put parentheses again and enter the fraction, guys. 12 divided by, as you learned in chapter 6 and 5, guys, I taught you how to do those square roots. So you press the second, x squared, and 35, and close. And I'm gonna pause here until a student tell me what the answer that is correct. Let's do the second one, guys. T, you notice the Z in the T, Z when sigma is known and T when sigma is not known. That's from chapter 6. So let's do 10.1. And please, guys, do it together because you're gonna need to know how to do that probably. Unless if you're using the calculator program, it will do everything for you. You will see that in this today. Square root of 12. Out and close. Can you guys share the answer with me? What would you get here? Equal. Okay, negative 0.9. Yes, that is correct. And the next one, let's do the last one. This is for the proportion Z 0.55 minus 0.52 divide by 0.55 times 0.45. See, I open the square root and just put the division here, 200. And let's get the answer. Oh, I made a mistake, probably. Oh, there's no parentheses here. Sorry. So, no. There you go. You don't need parentheses for the bottom. So it's 0.85. And I think the T and the Z should ring a bell. T is when sigma is not known, population standard deviation, Z when sigma is known. You're gonna see that. All right. So if p-value is less than alpha, we reject HO. If p-value is more than alpha, we fail to reject HO. Here's a, I would tell students, remember it this way. P-value low, HO must go. P-value low, HO must go. So if the p-value of hypothesis test is 0.0237, and if alpha is 0.05, what would be the decision, guys? Can someone tell me? You should reject or fail to reject the null hypothesis. So the p-value is less than alpha. This is the p-value, and this is alpha. Okay, let's see. Reject, exactly. Reject HO. Now he changed alpha. Look what happens when we change alpha to 0.01, guys. That's very important, that level of significance. Now the p-value becomes more than 0.01. So if the alpha is 0.01, you should fail to reject the null hypothesis. Okay. So how we're going to determine the p-value, you're going to see that. But as I told you guys, when we did a left tail test, I marked the p-value as an area to the left on the normal curve. When we showed you what a right tail test, I marked the p-value as an area in the right tail. And for two tail test, I marked the p-value on both sides of the tail, right and left, because it could be right or it could be left. All right. I'm gonna stop here.